Good evening to all. Today is the last day section for our project-based class. Today we'll discuss about the how to create the 3D model in how to create the 3D model in staadpro. That is the last class. Okay, fine. First of all, I simply create a one. First of all, I create a one simple plan. Okay, first of all, I simply create my simple plan. So okay, first of all, I create on one same like one symmetrical plan only. Simply I take this symmetrical plan only. I simply draw this. This is my symmetrical all are symmetrical section. I simply draw this symmetrical plan. Then I mention my column names. This is my column names. I mention this column names C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12, C13, C14, C15, C16. The totally the 16 columns are there. Totally the symmetrical building. There are 16 columns are there. Our distance is the same like that. This is a 5 meter. I take this is a 6 meter. Then this is a 4 meter. Then this side, sorry, unsymmetrical. I take this unsymmetrical 4 meter. 5 meter is a 4 meters. Okay. There are 16 columns in this building. There are 16 columns. Okay. Yesterday we'll discuss about the two axis only, x and y axis. Today we'll discuss about the three axis x, y, z. Okay. The three axis today we'll discuss about the three axis. In this plane, the x axis is this way. Okay, the x axis is this one. Z portion is this way. Okay. Then y is the height. The y is the height distance. Okay. The first of all, how to create this node point? There are three node points: x direction, y direction, and z direction. The based on your graph also. The based on your graph, the center portion is a 0. Then you go for this value is a plus. Then this y direction also plus. Then go for this back direction is a minus. Then go to upward is a minus directions. Okay. Now it's clear. The based on this coordination, it's based on this graphical method. Then how to enter your coordination? I taken into only x and z coordination. Okay, only x and z. Why I tell about later. How to fix the height also. I take this. This is g plus 3 buildings. Okay, this is g plus 3. Then all height as I take this 3 meter, 3 meter, 3 meter. Then our column. I first of all I mentioned this column 16 columns 4, 5, 6, 7 is a x and z, 8, 9, 10, 11, 12, 13, then this side also 14, 15, 16 coordinate points. Okay, 16 coordinate points. Then how to take your x and y? Is that x and z? Why after I tell you? Okay, first point is z. This is our C1, is a starting point. Every building you take a symmetrical, unsymmetrical. The first point is a x is a 0. Okay, the x is a 0. Z also 0. The back side have no distance. Okay, 0 distance. So z is at 0. Then second column C2. The C2 column. This is our C2 column. Our x distance is the distance from 0 is a 5 meter. Is a no one. So 0. Our x distance is a 5. Z is a 0. Then third point starting at this point 5 plus 6. Totally 11 meter. The next point x is a column 3. The column 3 point is a 11 meter. Add this 5 plus 6. Next one finally fourth point. Fourth point we add that 5 plus 4 9. 9 plus 6 15. Add that point 15 comma 0. The first column will be over. Then next column line, the fifth column. The fifth column starting point x is a 0. Then z is a some distance is there. This is our z distance, right? This is our z distance. Distance is a 5 meter. This is our 5 meter. Then next point, same like that. X also same 5 meter. Then z also same Then seventh column also same like that. Result also 11, then x also 11, z also. Eighth point also same. 4, sorry, totally 15. Totally 15, result also 5. Next one is a ninth column. This column starting point is a 0. Then z is a, this is our 5, this is our 4. Totally 5 plus 4. Totally z is a 9. Then this point 10th column, the distance is a 5. 5 comma 9, same like that. 11th one, the 11th one also 11 comma 9. 12th point is the end point. Add this 5 plus 6 plus 4 in this x direction, totally 15 comma 9. This next one is a 13th column. Starting point is a 0. The z is a total distance 5 plus 4 plus 5, totally 14 meters. Okay. Then our 14th column, this is our 14th column. Same like that. X is a 5 meter. Then this is our z is a 14. Then same like that. 5, 6, 11, 14. Then last point. The last point is the same like that. You provided the 15 comma 14. Okay. This is a method to creating the x and z direction in this coordination. First of all, there is a any plan. You go for unsymmetrical, symmetrical, or any plan. You go for this same method. Okay. This is a easy one. First of all, I created this coordination. Then how to enter this coordination point in your staadpro? Same procedure. I directly go to my staadpro software. Okay, simply enter my statement. This is our new project. Okay, new project space. I simply created the 3 dimensions. Okay, I simply create the 3 dimension. Then unit is a meter. Then go for kilonewton. Then next and finish. Okay, next and finish. Then enter your node points. Yesterday we'll discuss about the 3 method. One is the geometry node method, snap node method, and the structural wizard. Then let's discuss about the geometry node method. How to enter this node point values. Then go for geometry, go to node points. Okay. Then go to node point, click this automatically. With 3 coordinates will be given. Already calculated this value in this manual also. Our first point is a 0, is that also 0. Then see this, our second point is a 5, 11, 15. 5, sorry, 5, 11, 15. The first row will be over. Next point, the fifth. This is also same 0, 5, 11, 15, but z is a 5. 0, 5, this is a 5, 5, 11, 5, z is a 15, is a 5. The second row will be calculated, so automatically the second row will be calculated. Then third line, the third line x also same 0, 5, 11, 15, but z is a 9 meters. Okay, same like that. 0, 9, and the next point is a 5, 9, then 15, 9, then sorry, 11, 9. Sorry, next one is a 11, 9, then 15, 9. Then next to last point. This is our last point. We'll go for your last point. This is 0, 14. So okay, 0, 14. Our result distance is a 14. The next point is a 5, 14. Then 11, 14. Then 15, 14. This automatically created your node points on this tab foundations. Okay, this is our plan view. I simply created the plan view for your staadpro also. This is my simple procedure for my plan view. Then how to create the elevation? My elevation view. This is our plan view will be created. Then I created my elevation views. Okay, I take this some elevation view. I approximately I take this. This is our footing value. This is our ground floor to ground level. The ground level height is a 14.5. This is our above the foot. Sorry, this is a ground footing to ground level height is a 1.2, and then the ground level to our floor slab is a totally 4 meter. Then next floors is a 3 meter, 3 meter. Okay, total is the ground floor is a G. This is G plus 1. This is G plus 2. Totally two floors, G plus 1 and G plus 2 also. Then how to create? First one is the 1.2 meter above the ground level. I provided the earth beams. Then how to create the height for your 1.2 meter? First of all, click this node point. Okay, the first of all click this node point. Then select your node cursor. Then select your node cursor. Then go to geometry. Then go to translation repeats. Okay, then go to geometry. Then create the translation repeat. Our height is a y directions. Okay, our height is a y direction. Is spacing. The spacing of the height is a 1.4 meters. I joined my two node points links. I simply click this link steps. Okay, I simply click this link steps. Okay, this is automatically it will be created my footing level to ground level. Then how to create at the grade beams? Earth beam, go to geometry, add beams, add beam from point to point. Then click this automatically, add your points. This automatically click this add points. Click this add this points also. This automatically created our grade beams. Simply it will be created the grade beams for this area. Next one is the ground floor beam. Simply click this, join this, all the beams is click this one to this one, this one to this one, this one to this one. Click this one to this one, this one to this one, this one to this one, this one to this one. This automatically it's created the ground beam. Then next site I created some first floor ground floor height. The next of all, this is a ground floor height. Our ground floor height is a total the ground floor to ground level to our floor ground floor slab height is a 4 meter. Then simply go to select your nodes. Okay, go for node cursor, control, then select your node points. Is automatically select your node points. Simply control and select this all the node points. Simply select this all the node points for your cursor. Then go to same procedure. Go to geometry. Then go to translation repeat. Go to y direction. Our ground floor height is a 4 meter. Simply click this 4 meter link steps. Click OK. Since automatically it's created the link step. Then go to geometry, add beam from point to point. Since automatically it's created your ground floor level to ground floor slabs is automatically it's created the ground floor slab also. This automatically it will be created. Same procedure also, simply click this node point and connected with all the beams also. This is automatically it's created the node points connected with this beams. The next step I taken into only one floor only. Okay, and I'll not go for G plus 2. I taken into G plus 1. And then go for same procedure. You select the node points. Then cut this section also. That is a easy method is there. You cut this section. Then select your node point is a easy. First of all, you know that the node numbers. How to know that the node numbers? Right click on your mouse. Go to labels. Okay, right click on your mouse. Go to labels. Click this node numbers. Apply. This automatically your node number will be visible. I cut this X direction and Z direction. My node number is a 33. I simply go for tools, go to cut section. My plane is a X and Z. Then our node point is a 33. Simply click this OK. Then go to node cursor. Simply select this node points only. See this node points only. Then go to geometry translation repeat. Then go to y direction. My first floor height is a 3 meter. Then click this link steps. Okay, it says automatically it will be created. Then joining in your beams. Go to geometry, add beam from point to point. This automatically is connected with this all the beams, also connected with all the beams, is automatically it's connected with all the beams for your same procedure. Same procedure will be follow on this beam connection. Automatically is connected with all the joints. Automatically it's connected with all the joints. This I simply created the G plus first floor. Then how to see the all the floors is the same procedure. Go to tools, set current input, you sorry, cut section, show all. This is automatically it's visible for this. This is our footing level to the ground level. This is a ground level to a ground floor slab level. This is our first floor. Then how to check your dimensions? How to check your dimensions for your buildings? How to check the dimensions? Go to dimensions, click this dimensions, displays is automatically check your dimensions. So 1.4 meter is a footing to ground level, then our ground level height is a 4 meter, then our height is a 3 meters. Okay, now it's clear. See, this is a simple method to creating in your model. Then another procedure, same procedure will be follow on this areas. Okay, another same procedure. So yesterday we'll briefly discuss about how to apply the material sizes and all the things also. There are five materials. The first one is to go to general material. I simply select my concrete, assign to view, assign yes. Yesterday class we'll basically discuss about how to apply the material. The previous parts is have detail is here, how to apply the materials and the sizes and all the things also. Okay, we will refer the previous section also, part 5 and 6. Then property, go to property dialog box. I simply created my define, go to properties size. I give the beam and column are same properties. Okay, I give the beam and column are same property. Go to assign to view, beam and column are same properties, so I give the assign to view, assign yes. This automatically it's a beam and columns are all are same properties. Okay, then go to next one is a support. Then go to next one is a support. Then I go to create, then I have a fixed support. Click this, add this is support, select your support, then go to is a isometric view. I simply change into plus z view, front view. I plus z view. Simply select this bottom, is a easy method. Simply select your bottom, then go to assign yes, then go to 3D view. See, is automatically it's create the supports for this all the conditions also. The supports for this all the conditions. So the first one is the material. Anyone do not know that how to apply the different beam size, refer this part 5 also. Okay, part 5 and part 6 will be refer, I will be given in detail also how to apply the different sizes and all the things also. Okay, then next step, the next step you go for this load and distribution. The next step is go for this load and distribution. The simple method, simply go for this same like a load case details, add. Simply go to load case detail. First one is a dead load. Next one is a live dead load also. The big load also I taken into dead load. Next one is a live load is a slab loads. Okay. The live load is a slab load. The first of all go to load case one. The load case one I apply my self-made for my buildings. Okay, self-made. I simply go to load case one, add. Add, go to self-made, add, close. Then apply my self-weight, assign to view, assign yes. This automatically it will be assigned for my self-weight. Then go to load case 2. The load case 2 is a brick load. Simply go to add. Brick load is a UDL, is a uniform distributor load. The uniform distributor load is a minus 14. So guys, simply attend the minus 14. Simply add this, close. I apply for my all the beams also. I apply for my all the beams. Go to select beam parallel to x direction. Select beam parallel to z direction. Then go to selected beams, assign yes. This automatically it will be acting on this all the beams for your brick load also. Then next one is the floor load. Next one is a floor load. Go to load cast details. The first of all, you know that the distance also. You are applying the floor load. You know that the distance. This is our slab. How to apply this slab? Simple procedure. First of all, go to I know this dimension. I click this dimensions for this distance. Go to dimensions display. This is a 1.4 meter, total 5.4. This is our height. This distance are all are same, right? This distance are all are same. So I cut this section. Go to labels. Go to node numbers. Okay, node numbers. Apply. Okay. I cut this 33 section. Okay. Go to tools. Cut section. Cut section XZ is a 33. Simply go to cut section is a 33. Okay. This is automatically I created the two-way slabs. Go to load cast to add. Load cast to, before you put this dimension also. Go to display. Display. This is our dimension. Then go to load cast 3. Then you added the load. Simply go to floor load. Then our live load or dead load. Already I know that how to calculate your live load and dead load. Approximately it will take this 3 kilonewton per meter square. Then our height. This is our slab height is a minimum is a 0. The maximum is a 1.4 plus 4 meter. Totally 5.4. Okay. Totally 5.4. X distance I taken into over distance. All are two-way slab. 5 plus 6 is a 11. 11 plus 4 is a 15. Minimum is a 0. Maximum is a 15. Then Z distance. Z distance the minimum is a 0. Maximum 5 plus 5 10. Z is a 14. The maximum distance is a 14. Click this add close. Says automatically it's created the same like a manual calculation also. Same the manual calculation load will be distributed on the slab also. Then go to tools cut section show all. Then how to apply the top of the floor same like that. Go to tools cut section X is it our plane is a 49. 49. Okay, same like that. Same procedure will be follow. Go to load case 3 add. Go to load case 3, go to floor loads. Okay, floor loads. The top of the load will be less. I apply the 2.5. The minimum height is a 0. The maximum is a 1.4 plus 4, 5.4 plus 3. 8.4 our maximum height. X is the same distance. 5 plus 6 is 11. 11 plus 4 is a 15. Our distance is a 15. Z also same. Z 5 plus 5 10 is a 14 meters. Okay, our result is a 14 meter. Then click this add close. See this automatically it's created the distance for your building. Then go to tools cut section show all. This is automatically our cut section. So also is automatically I created my brick load, then the slab load also. So okay, sometimes it will be created in this at the bottom load. Go to edit option. Sorry, it's taken into not a 0. It's taken into 5 point starting distance is a 5.4 meters. Okay, 5.4 meter is a change. Close it. See this automatically. Then go to edit option. This also sorry 0 not a 0. It's taken into 4 meter. Its starting distance is a 4. Like this automatically it changes into ground floor slab and bottom floor slab also. Then how to combination load, how to combination into factor of safety. Go to load case details add. Then go to define combination. The take over into preloads in this side 1.5 1.5 1.5 into factor of safety. Then adds is automatically converted into factor of safety. Automatically it's go to into 1.5. Automatically it's go for 1.5. Then go to analyze, add, close. Then go to run analyze, save. Automatically the structure will be analyzed. Okay, automatically the structure will be analyzed. Finally our model is a zero errors and zero warning. It's a no problem. Then you follow the same procedure. Then you follow your same procedure also. Yesterday in the previous class we'll discuss about how to see the post processing values, then your bending moment reactions, and all the values. This is our moment value, this is our reaction value, and all the values will be given. You check that previous part 3 and part 4 also. Okay, part 3 and part 4 also, you'll see this how to calculate the bending moment, and therefore how to design your normal design and RC design also. This is the easy method to creating the any 3D structure for your buildings. Okay, this is simple method. The next step is how to take the reports from STAR also. How to take the reports. Okay, the first of all, go to post processing. This is our post processing. Then go to dimensions. I remove that dimensions. Okay, as is bending moment, I have to take my bending moment image, whole bending moment image. First of all, right click on your mouse, take picture. Click this automatically. It's a take picture. This is my bending moment. I need a shear force. Click this shear force diagram, take picture. Automatically you will be take this all the values. Then how to export your Excel also. First of all, go to file, go to report setup. So report setup, go to, these are input values, I need the output values is a picture. I take this two picture, simply select this picture, transfer to this side. Says automatically picture 1, picture 2. Simply click OK. Then how to export this report? Go to file, go to export options. Okay, go to export, or sorry, once again, go to file, report setup, export report. To a report, you may be in this Excel or anyone, simply click this. I need the MS Word for my shear force and bending images. Okay, I simply save that file. Automatically it will be open on this board. Also you will be edited all the values also, not only for shear force bending moment values, it will be taken into all the values also. Okay, it's not only shear force bending moment values, it's the all the values is directly from this Excel also. So again, it will be loading. Yeah, so automatically it will be open. The sheet will be prepared at your name and type of structure, the number of node points, elements. This is our load cases will be there, whole structure. Then your two diagrams also visible on this page. This is our bending moment diagram. This is our shear force diagram for your Excel also. Any modification, you take this print also. Okay. Then other reports. This is our bending moment and shear force. I need another values for this. Simply go for report setup, go to output values. These are the node displacement, all the reports are there. Simply click this, the browser on this side, simply okay, go to export option. This is my need the advanced earthquake checks, advanced quantity reports, and all the page. This is simple procedure to take this all the reports. Okay, this is our output report, output node displacement, beam force detail. I need the beam force detail. Simply click this, transfer to this side. Simply click OK, go to File, Export Report option in MS Word. Automatically, it's taken into all the files in MS Word also. This is the procedure to taking the any reports in this Excel also. Okay, this is the any Excel. Then same like a concrete design, all the reactions will be taken also. It's like a tables, all the values will be given. Now it's clear. How to take the 3D view? Right click on your mouse. Sorry, once again. Right click on your mouse, go to 3D rendering. I need the 3D rendering picture. Simply click this right click, go to take picture option, take picture. You taken into an Excel sheet also in your 3D model, all the values also. Okay. The next the analyze procedure, shear force, bending moment, beam design, column design, footing design. Yesterday will be briefly discussed on our the advanced RC, same procedure. The structure will be different. The part, the 2D structure will be discussed. The today will be 3D model also. 3D model apply for a material and all the things also. Okay. Now it's clear how to create the 3D models and all the things also. Okay. This is a method to creating the reports and all the values. Okay, fine. I hope you understand. You understand about the something about the framed structure, then how to analyze the staadpro and manual some calculations also. Okay, fine. Now itself I completed the 7 days section for today itself. The day one is how to manual check for your slabs, and day two beams and columns. Then how to create the one 2D structure for designing of the beams and columns and footing. Today we'll discuss about the 3D structure also, how to take the printout and all the things also. Okay, fine. Now itself I complete the section itself. Please fill the attendance form and feedback for this overall section. Okay, attend the 7 days section. You will be fill the feedback form also. Okay, not only for today's section. This is the last section. Please fill the today's overall 7 days section feedback on this today itself. The certificate will be given by within 1 week. 1 week you will be receive your certificate on this respective mail ID. The 80 percentage who can attend the 5 days completely, you will give the certificate also at 80 percentage. The based on your take the five compulsory for 5 days, you will be take the attendance also. So only give the certificate for this participants. Okay, thank you all. I put this link in this chat box. Please fill this attendance and overall feedback for this 7 days sections. Okay, thank you all for this 7 days week. The next the Monday will be same time. It's going on this Revit software also. If you free, we will be say this YouTube live also. It's also certificate is there. This program certificate will be received on this next 7 days. Within 7 days, you will be received this certificate on your mail ID also. Please fill your mail ID correctly. Okay. Thank you all. Thank you.